we exchange experiences and best practices across these fields. طبعا احنا بنرحب فيكم جميعا في منتدى الابتكار، وهو يعقد بانتظام خلال العام، ودائما حريصين على أن يكون دائما في عندنا ضيوف نثري هذه الخبرات ونتبادل الخبرات. طبعا احنا رحبوا معي جميعا بروفيسور مايا أكسلا. بروفيسور مايا أكسلا هي ضيفتنا المتميزة من جامعة هلسنكي، وهي باحثة في تعليم العلوم، وتمتلك خبرة تتجاوز 30 عام في تطوير تعليم العلوم والتكنولوجيا والهندسة والرياضيات. طبعا الدكتورة مايا أكسلا تشغل منصب المديرة التأسيسية لشبكة العلوم والرياضيات والتكنولوجيا في فنلندا اللي تسمى لوما سنتر، وهي من عام 2003 للعام 2025 وهي تشغل هذا المنصب، وهي مؤسس. طبعا هو بيشمل 11 جامعة و13 مركز إقليمي في فنلندا. أدارت هذا البرنامج لسنوات عديدة لبناء ودعم قدرات المعلمين ومشاركة الشباب والاستدامة، وأسست منتدى لومات للبحث العلمي، وهو منتدى أيضا دولي يشمل مجلة علمية وندوات مختصة في منهجية البحث القائم على التصميم المشترك. طبعا دكتورة مايا تحمل درجة الدكتوراه في الكيمياء، وأيضا في Teacher Education Programs. أشرفت على الرسائل دكتوراه وماجستير، وأنتجت أكثر من 450 منشور علمي في مجال الاستدامة والتحول الرقمي وتطوير المعلمين والتعليم غير الرسمي. طبعا تتعاون الدكتورة مايا من خلال شبكة العلوم والرياضيات والتكنولوجيا مع عشرات الدول في مختلف القارات مثل أفريقيا وآسيا وأستراليا وأوروبا وأمريكا الجنوبية، وهي عضو في لجنة اليونسكو الفنلندية وعضو في المجلس الاستشاري بجامعة هلسنكي. طبعا إحنا في جمعية ابتكار لدينا شراكة مع مركز لوما من العام 2018، والجامعة الأردنية تشاركنا في هذه الشراكة، حتى أنه تعقد في الجامعة الأردنية من العام 2018 مسابقة الممارسات التعليمية الفضلى بالتعاون مع مركز لوما. طبعا هاي نهج ستيم. احنا لنا الشرف في انه بدأ هذا التعاون من العام 2018. بدأ العمل مع الجامعة الأردنية في العام 2014، وبعد ذلك شاركنا مع لوما سنتر في مسابقة دولية، وعقدنا شراكة مع مركز لوما بقيادة الدكتورة مايا. طبعا لدينا عمل في المسابقات كما ذكرنا، ولدينا تعاون أيضا في كورس برنامج تدريبي للمعلمين العلوم والرياضيات والتكنولوجيا مع جامعة هلسنكي. وفي هذا العام احنا نعمل للعام الثالث على التوالي في برنامج ستارت لوما دبلوما اللي يعقد بهذه الشراكة اللي أصبحت متجذرة، ويعني أثمرت بشكل كبير جدا في التعاون مع مركز لوما والجامعة الأردنية في تدريب المعلمين من خلال منصة عن بعد، ومن خلال العمل مع المعلمين والطلبة في هذا المجال، طلبة الجامعة طبعا وأيضا نعمل معهم في الويبينارز والمؤتمرات اللي تعقدها هذه الشبكة، وإحنا مشاركين فاعلين معها. طبعا شكرا للدكتورة مايا لهذا العمل وهذا التعاون المستمر. We are thank you Dr. Maya for your collaboration with the association and with the University of Jordan. We are here now. We are talking about the Innovation Forum, and we are welcoming Prof. Maya in collaboration with the Jordanian Chemical Society and the School of Science, the Department of Chemistry at the University of Jordan. We are now in this lecture, and we have the honor to hear from you the lecture entitled Enhancing Teachers' Professional Agency in Science and Chemistry Education. Thank you, Prof. Maya. Now I invite Dr. Prof. Murad Al-Damin, the head of the Department of Chemistry at the School of Science and the University of Jordan, to talk. Dr. Murad. Dr. Fadwa.
Yeah, how are you? Do you hear me?
Hi, Doctor. Hi, Dr. Murad.
I don't know the time at Dr. Maya, evening or morning, so good evening and good morning and good afternoon. And welcome, Dr. Maya, to, I don't know, is the cam. This is the cam. Welcome, Dr. Maya, for this lecture. And thank you for these lectures that the Department of Chemistry, Iptikar, and JCS are thrilled to present today. Our guest speaker, Professor Maya Aksela, coming from Helsinki University. And I read some a little bit as I'm interested in pedagogy. That Professor Alexa is a pioneer in science education, which is something important to connect between the normal scientists like chemists, that we are practical side, and the pedagogy, that they are other field of science. Professor Maya, she is the former head of LUMA Center, and she is here to share her expertise on how we can better support and empower our science and chemistry teachers. The floor is yours, Professor Maya, to present the talk, Enhancing Teachers' Professional Agency in Science and Chemistry Education. So thank you. And
it does. Okay, can I share my slides now?
Yes.
Okay. Yes. Okay.
Thank you, Dr. Maya.
Okay, can you see now them? Okay.
Yes, we can see.
Is it fine?
Yeah.
You can see the whole slide there.
You can make it as a slideshow, present it as a like.
Where is it? I try to find out how to get it from my. Oh yeah,
the
there.
bottom of
There
the.
now. Is it
yeah.
is it now fine? Okay. Can you see my slide? Yes.
Yes,
we can.
Okay. So I try to say in your language, Assalamu alaikum. Good evening. It's my great pleasure and an honor to share some experiences of our teacher education in Finland and discuss with you. And I'm also open for questions. As you know, as a scientist, that scientists have always more questions than answers. So if you have any questions, please feel free to ask. So a little bit more about my background, and thank you for your kind introduction. I have background both in science and in education. First, I studied science, chemistry, physics, mathematics, and computing science. And I was doing PhD studies in Canada. in chemistry, actually computer-based chemistry. And then I decided that I would like to be in education and in teacher education. So I started to do my second PhD studies in science education, chemistry education. And now I have been 25 years in Department of Chemistry, Faculty of Science. And this year we celebrate our 25th anniversary of our teacher education unit I built to Department of Chemistry. And now I'm sharing those backgrounds and info about how we educate teachers in chemistry in Finland. It's also integrated to in-service training. So that's my experience and my background. I'm also mother and I'm grandmother of 3 grandsons. So always makers of future are at my heart. So thank you for your kind invitation and sunny greetings from Finland. It's very sunny and nice evening in Helsinki. And this left photo is from my home area. We are living at close to Baltic Sea. So this it's not lake, it's Baltic Sea, but we have 200,000 lakes in Finland. So if you like to know more about Finland, please visit webpage Visit Finland. So you can get more information. And the right photo is from my visit in Jordan. And I still have great memories at my heart. And I met so lovely people in Jordan. And also I loved your culture and your food. And so it was great experience for me and always will be at my heart. And as you told about the study program, I also thank you for this great collaboration, almost 8 years already. So as I always say that together we are more. So I think when we are learning through sharing, we are learning from each others and making better world. And I can say that I have learned a lot from you and hopefully you are learned from us. So over 70 countries has participated to start the LUMA program that we started 10 years ago. And now we have a fourth form of study program, and you have also participated on it. You have done excellent science clubs in Jordan, and it has a great opportunity to collaborate with you. If you later on want to go and see those links, I have asked you to share my slides and you can study these things in details. So as we all know, teachers are the agents of changes and quality of education is very important for our society and well-being and so on. And in Finland, we really appreciate our teachers and our teacher education. And we really think that teachers are the agents of changes. And maybe that's why I'm also a teacher educator nowadays. I always share this motto, every teacher affects on society about 100 years. First as a teacher and then through her, his students. So it's a big effect on the world. And also that science opens opportunities for making better world and sustainable future. So as you shared, I'm from University of Helsinki. And it's our biggest and oldest university in Finland. We have 11 universities, and you can study science in 8 universities. And we have 40,000 students and about 9,000 staff at University of Helsinki. And I'm working at Faculty of Science. We have 11 faculties at our university. And the Faculty of Science is the biggest faculty at University of Helsinki. And our top research areas are future technologies, sustainable planet, precision health, and learning and evolving societies. And it has been my great pleasure to work at Faculty of Science and Department of Chemistry. And also at our department, sustainability is the main theme. And we have different units there. I'm working in chemistry education unit and collaborating with all other units at our department. And we have 4 main research fields, and they are energy, health and environment, and materials. And we have altogether 30 different research groups. Half of our faculty professor members are abroad, and it's happy to say that we have also 1 faculty member from Jordan, and I have good collaboration with him. And as I said at the beginning, my unit celebrates 25th anniversary this year. And later on, you can open this link. There is the article of this model. And also we just published the chemistry news. And there are a lot of papers also in English. And my unit is educating research-oriented chemistry teacher. And this evidence means that they have good background both in chemistry and chemistry education. And here you can see those main topics that we are focusing. And in the middle, there are more like these pedagogical contents. And around there are those main topics also in chemistry. So it was great honor to start to build new program for chemistry teachers 25 years ago. And why our department decided to build this kind of own unit was because there was a challenging how to get enough talent students in chemistry to university. And our vice directors, they understood that if you have strong chemistry teacher education, then you can get more good talent students also to study chemistry. And it looks like that it's happened like this, that those teachers who are talented and keen on teaching chemistry at school, they get interest to students, and then they start to study also science at universities. So that's the background. Also, our chemical industry was supporting that we have this unit at Department of Chemistry. They see that also industry is stronger when we have talent students and chemists or scientists. So in our program, we are focusing, integrating our chemistry expertise and also pedagogical knowledge, and also societal collaboration with, for example, with companies. And if you open this chemistry news later on, you can find out a lot of articles in chemistry from our department, but also from our unit. So when we started to build this program 25 years ago, there should be a balance between chemistry and chemistry education. And when you are studying to be a chemistry teacher, you are studying 5 years at university, first bachelor in chemistry and then master's in chemistry, and you can specialize in chemistry education. And here you can see that we have educated about 500 chemistry teachers until this, and we have also doctoral program. I have supervised 16 completed doctoral degrees in chemistry education, and 10 are still ongoing. And our chemistry teachers, they are studying chemistry as a major, but then they can choose minor subject. And this minor subject, it can be biology, physics, mathematics, computing science, or what they like. So we have a quite good balance at Faculty of Science. They are studying those chemistry education courses, chemistry courses, then second subject, and then they spend 1 year in Faculty of Education, and there they have more of these general education courses, and then also training school practice. And because our university and our faculty and our department has specialized in sustainability, it's also strongly in our program. And always when I start my lectures, I draw this heart to table, and then I ask my students that what is the most important for teacher when she or he will be at school. And of course it's science important, but then they finally say that student, and then I write the student word at the heart. And we are trying to teach our student teachers and teachers how to handle chemistry or science in macro, sub-micro, and symbolic levels. As you know, this Johnstone model from 1991, he found that why chemistry is so difficult for students, and he opened this triangle that usually we teachers are at sub-micro or symbolic level, but our students are at macro level. So if we really want to connect our students, we have to start from macroscopic level. And we have found that it's very important to make also relevancy of chemistry or science. And that's why we also open this green and sustainable chemistry, global responsibility, and socio-chemical sustainability things in our teacher education. For example, I have this kind of course, sustainable chemistry and circular economy. So I'm also collaborating with chemists in that course. And we are using that our role is this pedagogical content knowledge. Those who are teaching chemistry, they are teaching content knowledge. But our role in our courses is how to meet students at students' level. And that's why we need this pedagogical content knowledge. And we are collaborating closely with our scientists. So here are some examples about our scientist research groups and what are they studying at Department of Chemistry. I received these slides from Maija Mäntymäki, so you can see what kind of collaboration we are doing with our scientists, and we are trying to open the authentic modern chemistry for our teachers. So a lot of new things also for me. although I'm a chemist. And then green energy is also one research topic. And we try to open this modern chemistry to our student teachers. And the third important topic is health and environment. And as you can see, there are two main areas, synthesis and analysis. And many research groups working at this topic too. Okay, that was my background and my units. And now I'm going to go details in teacher education. About 70 years ago, our government decided that all teachers are studying at universities to be teachers, and they all are finishing master's degree. So you can't go to school as a teacher with bachelor degree. All have to have master's degree. And because we are far away from Europe and we don't have a lot of minerals, so we always think that education is our how to say minerals. So that we are making good society when we have a good education system and we have high quality teacher education. So it was a wise decision 70 years ago from our government. And I think that we are good because we have so talented teachers. I'm a member of this National Teacher Education Forum, and we just published our teacher education vision in Finland and how we support teachers' expertise and agency. It's the core of the teacher education and also this continuous learning. As we all know, there are a lot of challenging in the world nowadays, so we have to check out our teacher education whole time and find out that it's evidence-based and it's continuous. So you can find out in this photo those main things that we should point out in our teacher education. And you can find out the report in details in English if you go later on to open this link. So these things we try to find out also in chemistry teacher education program. And what are we doing just now is we are trying to find out this kind of quality standards for teacher education, so that all teacher education at different universities are quality and collaborating also with each others. And now finally to our model. We found 25 years ago that it's important to find out this kind of teacher education that it meets student. That if you are teaching orbitals or very abstract concepts and phenomena, how do you meet student level? For us, it's easy as scientists. It is easy to explain orbitals and different things. But as we all know, it's one of the most difficult concepts or phenomena for students at schools. So all teaching what we are doing at our courses is so-called pedagogical content knowledge, and what we know from research, how student learns orbitals, what kind of challenges students have, and what kind of opportunities and teaching methods you can use. For example, visualization, molecular modeling, or experimental works that you can open these difficult concepts and phenomena at student level. And we are educating teachers who are teaching students who are from 12 years to 18 years, so at high school level. And here in that photo, we are explaining that what things are especially important in addition of chemistry, and how we use this kind of co-design system so that theory and practice are at good balance. And okay, maybe I go in details, and you remember that this is a summary of this all things. But our student teachers, they have to understand the research in chemistry and also in chemistry education, so that there is a good balance. So you all maybe know this pedagogical content knowledge. Schulman published it already 40 years ago. So there's the most important things: content knowledge, pedagogical knowledge, and pedagogical content knowledge. And at Department of Chemistry, we are teaching content knowledge and pedagogical content knowledge. And this pedagogical knowledge is has been taught at the Faculty of Education. And my unit is specialized also ICT, so how to use computers and AI in teacher education. Actually, 3 years ago, we started to teach AI in chemistry education, and try to find out those opportunities and challenges. As we know, there are a lot of challenges also using AI. But that's those concepts. And when you open this article, you can read details. And we are using this kind of 5 core domains during our courses. So this orientation towards science teaching, what kind of inquiry-based strategies, for example, relevance things they are, and knowledge of curriculum, what are the curriculum in chemistry and science, but especially our courses are concentrating on these yellow things. We have to understand how students is learning chemistry and how student is understanding chemistry. And so during our courses, we build on using latest empirical methods, research literature, and we try to find out these prior knowledge and difficulties, and also alternative concepts. That's the main thing in our teacher education at Department of Chemistry. And then how to meet those students. Knowledge and teaching strategies are very important. How to use experimental working, how to use molecular modeling, how to use AI simulations, and so on. So, for example, I have specialized molecular modeling because I was computer chemistry scientist when I was young. So we are trying to find out how those abstract concepts can be open through molecular modeling. I have also specialized microcomputer-based laboratory tools, how to use them in practical work. But as we all know, also assessment is very important. How to use different kind of assessments. And in Finland, we are pointing out formative assessment. So I think there are at least over 70 different ways how to use formative assessment. But formative assessment supports students' understanding. not only at the end of the course, but during this chemistry learning. And here is summary of our courses in chemistry education. So you can find out that we have there many courses, and we have bachelor thesis and master's thesis. And we start these courses beside chemistry courses from the first year. They are mainly studying chemistry in first year, and then they have only one course in our unit. And then second year, they have more how to use practical work or inquiry at chemistry teaching. And these concepts and phenomena in chemistry education is very important also for our teachers. But because we are specialized in computers and information and communication technology, we have own course from it, and also sustainability. And in our Finnish curriculum is very important, this integrated STEM. So how to study phenomena. So they are not only chemistry, they are science, they are many things, also mathematics. So this course is also very important. And because we want to open this contemporary science and future research, so our student teachers are collaborating with our scientists a lot and visiting research groups and find out how scientists are studying new science and how they can apply it to high school. And our students can do bachelor in chemistry or in chemistry education, but master's thesis, they are all studying in chemistry education context. So usually those courses are 5 credits nowadays. And how we empower our students in chemistry education. We are using this kind of co-design approach, and so that they are collaborating a lot with each other during our courses. They have a lot of different kind of exercises, but we have also opportunity to collaborate with schools. We have this kind of LUMA Lab Cadelin. I'm sharing it later on. And about 4,000 students are visiting us every year. And our student teachers are guiding them during the courses, or also we have some students who get salary that they are guiding those school students. So, but also this relational agency means that they are collaborating with also companies. Our LUMA Lab Cadelin has 10 companies who are supporting us and collaborating with us. And that's we have found very, very important for our student teachers that they are collaborating with teachers at school, meeting students during their studies, and also collaborating with scientists, companies. So they can open this, how to say, relevancy of chemistry or science. So we have found that this kind of co-design approach where students and our partners are collaborating during their courses, it's increased teacher empowerment and also shared expertise. So they get authentic resources, and it also promotes or increases dynamic pedagogical content knowledge and coherency. University theory and school practice are linked to same design. And this kind of good experiences we have found during these years. We have found that it supports the professional, motivation, because every course has some tasks with students or other partners. We have found that it's very motivating students to be teachers. So as we have grown up to be chemists, so teachers are growing up to be teachers during these 5 years. And as a methodology, we have using this kind of design-based research as a framework. So as I told earlier, this empirical problem analysis are the needs, teachers or student teachers or challenges. And then we are opening this science, newest and newest learning research, and co-designing with different partners the activities, and then we are testing them and collecting data, and we get results, not only these innovations, but also we get understanding of theory, how does it affect on, for example, relevancy. And then when we get those solutions, we are applying them to teacher education. We have built over 40 MOOCs, online MOOCs for teachers also, that they can study at their schools. For example, we have these 13 LUMA centers at our universities. So some small schools are far away from universities, then they can study also online. If you are keen on this co-design approach, I have published one paper, open paper, and you can read it, details how we co-design novel things with scientists and partners during this co-design approach. Here is one example how we have developed novel activities with our chemists. This sustainable ionic liquids context is one of research topic at our department. And one my master students was visiting this research group and learned how to use this ionic liquids context. And then we use this co-design approach, and with scientists we built a new activity, practical activity, and then we tested it in our LUMA lab Kadolin, where our students from schools are visiting. And then later on we published this also international journal. So if you like to know details, you can open this link, and there is a scientific paper about this topic. This has been very, motivating our high school students, that we are opening this real, authentic chemistry. And here is one example from Professor Timo Repo and his research group. We are trying to open this climate change and how chemists are affecting on those solutions. So here is one example that our high school students have also visited Professor Timo Revo's research group, and they have done this kind of materials, and also teachers can learn from their materials. So we are not only co-designing these things with teachers and scientists, also those high school students has participated to our development. So as I mentioned earlier on, that 18 years ago, I built this LUMA lab Kadolin, and it's at our Department of Chemistry's laboratory, modern laboratory, where we have free of charge visits from schools. But for us, it's also research and development and education hub. But during those study visits, students can meet scientists, they can do those novel laboratory activities, they are testing our pilots. And but we have also non-formal science clubs, science camps, science fairs, a lot of in-service training for those novel activities. Very how to say, motivating has been also birthday parties in science. So every week about 3 birthday parties are at our department. They are doing chemistry experiments and our student teachers are guiding them. So it's also good practice for them. And we have also online e-visits. And last year, how many 10,000 students were doing those online visits, and our scientists are also talking to students and teachers. And 23 years ago, I built first LUMA Center at University of Helsinki for promoting collaboration between schools, industry and scientists. And then all other universities wanted to get also this LUMA Center. So nowadays we have 13 LUMA centers, and our government gave us national task, and now the name is LUMA Center Finland. I was the head of the network 12 years, but now I said that my last years at professor, I want to concentrate more in my main work, and now I'm only, they called me LUMA Science Ambassador, so I'm supporting this network. So this network has been very successful, and how many 1 million students has been studied with science, all mathematics, all sciences and technology things through LUMA Center Finland activities. So I always say that together we are more, and I think it has been a good opportunity. And all those things that we are doing at LUMA Lab Gathering, we are sharing to whole Finland through LUMA Center Finland network. And as I said earlier, online courses are very important for us. So we have built a lot of this kind of courses for teachers and students. This was the first one I built, this Science Now and in the Future. And the first course was about chemistry as a science and its role in society. And there were about 50 scientists who were collaborating with us. And we were opening how chemistry research is done, what is research now and in future, how it's connected to sustainability. So there were short interview clips, there were chemistry experts' presentation, there were articles, and there were assignments. And for example, one topic was system thinking. And here is also article about system thinking. We have studied how chemists are using system thinking. And it's shared to teachers and students through this course. And these courses are free of charge in our DigiCampus. DigiCampus is platform for 11 universities. So students at high school and their teachers can study these courses and they are free of charge. And one new thing I started 1 year ago, we started this kind of LUMA Stars program for youth. And we are co-designing this program with high school students, their questions, their needs, their wishes. And those young people, they are visiting research groups at Department of Chemistry, and they are making online clubs for other high school students and teachers. And it's our research projects also. We want to learn how students' agencies promoting also other students and also teachers. Because all these new research in chemistry is new also for teachers. And as we all know that science is going so fast, someone has said that every day it's published about 5,000 scientist papers in chemistry. So if I think, although our books at schools are excellent, but some things are like history. So if you really want to get students engaged on chemistry, it's very important that they have opportunities to meet chemistry and science nowadays, and also understand that they have also opportunities in future to make better world. So this is our pilot, and we really like to strengthen it in whole Finland. We have a LUMA Stars camp for high school students this summer. We have also LUMA Stars program for teachers. Okay, and as I mentioned earlier, we try to find out opportunities and challenges how use AI in chemistry education. And was it 2 years ago I started this kind of AI forum for teachers, and opening how to open content knowledge in chemistry and chemistry learning using AI. We have published some papers about it, and that's also our research topic. And so we have found that it's better to know also what are the opportunities to use AI, not only those challenges. And as you all chemists know, that in chemistry, they are using a lot AI in chemistry research also. So I have taught already 50 minutes, and I think it's time for your questions. But if you like to know more about LUMA, LUMA means STEM. We have published ebook in English. There are 100 examples how we are collaborating with schools and also companies, and we have 100 writers in that ebook, and it's free of charge. So you can go there and upload it for you, download for you. We have also social media channels, and for example, like I say, we have TikTok channel in chemistry, and it's very popular. I think 1 million students in Finland are using our TikTok in chemistry. So our scientists are sharing their new research in chemistry, or our students, teachers are sharing how they demonstrate experiments in chemistry. And we have also YouTube channel. So, makers of future at our hearts, together we are more. And I say in your language, Shukran lakum, kiitos in Finnish. And now it's time for your questions. It's my pleasure to answer.
Thank you so much, Prof. Maija, for your rich, insightful, and inspiring lecture. As we used to learn from you always, we learned many from your experience, and we are looking forward to continue our collaboration with LUMA Center and with you especially. We have here in the lecture many professors from Department of Chemistry and from the Jordanian Chemical Society, and we have doctors from the science teacher education program at the University of Jordan, and we have many university students teach in the teacher education program. And we have many chemistry and science teachers in this forum. I invite Professor Abir Al-Bawab. She is the head of the Jordanian Chemical Society. If there is any notes from her or
Okay.
anything, you can say.
First of all, allow me to welcome you again. Many people
Thank you.
welcome you, but after
Thank
the
you.
lecture, the welcoming is totally different.
Thank
After
you.
we heard your lectures and your important notes, and you actually open our mind to many points we have to discuss it and to take care of it. But first of all, let me thank you for taking this
Thank you.
chance to join us, to give us this important lectures, and to be in cooperation with Jordan and all this go to Thuraya, Professor, I will call her Professor because she's really my professor. She doesn't like to know that, but she's my professor.
Okay.
long time ago.
Nice to hear.
Okay, difference 2 years or 1 year.
Yeah,
She was my
yeah.
teacher,
Okay.
supervisor. Actually,
Mm.
in the end of the lecture, there was I didn't introduce myself. Dr. Suraya introduced me. I want to welcome you in behalf of the Jordanian Chemical Society. Our Jordanian Chemical Society is like an old society comparing to us. This year we will celebrate the 50 years in the establishing. Now I'm the president, but many presidents were for the society, were very hard for it. And we are very pleasure. We are very honored to be in cooperation with the Innovation Society with the Miss Suraya, Mrs. Suraya, Miss Suraya. This is what our lecture to be together. I would like to welcome all the teachers from the schools. Actually, they are more important than us as a professor in chemistry department. We would like to be some education professor with us, but I don't think we have a lot or we have none. It was very interesting that in your country where the education and the science get in a cooperation in the education and in the schools. This case was already in our schools, in our university, but something happened and they totally separate the education from the science and leave the floor for people, for the master to combine if they like to combine and go to the teaching process. But I think nowadays with the IA and with the different approach of teaching and a lot of modification, I think the connection should be much related than before. It's not enough just for us to listen to one lecture or to go to a workshop to realize how it's very important. But taking in consideration the LUMA approach, this is very nice for you country, and we were happy that we are cooperation with you and we are learning from you as much as we can, and our students really are getting benefit out of that. I have one question for you after I welcome you and all this program that talk.
Thank you.
Now considering the AI, it's a very short 2 letters for a huge road that we must all go through it. Student, teach, professors, administration, everything. Your experience is like a few years with it, but I think it's more rich than our experience. You just put like 1 or 2 slides, but I would like your opinion about it. It's very important to be in teaching, but we cannot control it sometimes, even with the innovation. This is very more harder than education, I guess.
Yeah, very good question. Thank you. And thank you for your kind words. It's great to collaborate with you and also learn from you. So together we are more, I always say. So if I think AI, I have studied computing science when I was young. And 10 years ago, I was visiting in China. China built also LUMA Center China to Beijing. And I was there, and that time they introduced me AI Center in education. And I was visiting there 10 years ago, and then I found that now I have to start to study new thing. And they were very good in it. They were supporting students' learning in many ways. And so I started 10 years to study how to use AI and machine learning. And nowadays we are trying to find out how to use these agentic agents. And it's like studying, I feel that I'm studying like alphabetics of it. So every day, so many new things are arriving, and I have to be awake up and be like a student at school. So it's so huge area and a lot of things to learn. But we have found its opportunity. If you are using critical thinking, that you think that it's opportunity, it's like brainstorm. You are getting new ideas for your teaching, your curriculum, but you have to always use your brains and use critical thinking and also think those ethical things. But we have seen a lot of good opportunities. It gives us more freedom to think and discuss. So, and I have found many times that I have never thought these kind of things, and they are good ideas. So I have found it very positive. But I'm learning every day. I'm really like a student in AI.
Oh, so you advise us to learn with our student, I guess.
Yeah,
It's not just enough to watch or to just read or attend some lectures. We have to learn by default.
And I want to ask that this kind of co-design approach is very good supporting. When I built this kind of AI chemistry teacher forum for teachers at school, we were co-designing those topics together. That what kind of needs teachers have at school, and then we co-designed the program for teachers together. So our role as a university was to give research-based evidences how to use AI, and then teachers were practicing those new things at school, and then next time they were sharing those things that they have learned and what kind of challenges they had. And we all were learning from each other. I was learning from teachers, and teachers hopefully learned for us. So I think that this kind of co-designing is good tool when you are using AI, or if you are studying new things in chemistry.
Okay,
also.
Thank you and welcome again, and thank you very, very much for your lectures and your answers. Thank you.
Thank you.
I will leave the floor for another question for any of the audience, and Dr. Ms. Suraya will lead the road now.
Kiitos.
Thank you, Dr. Maija. Thank you, Dr. Abir. If anyone wants to add or have a question, please raise your hand. Or you can put your question in the chat.
Yes, and you can also send me email if you have any questions. Yes, please.
We have, I think I see.
And there is one hand. Yeah, please.
Dr. Mansour Matarna, I see Dr. Hiba, Dr. Jawahir. If you have any questions.
Yeah, please.
Dr. Fadwa.
For your students, Dr. Jawahir.
Let them unmute themselves, okay? Dr. Fadwa, Dr. Mansour.
Yeah.
Hello.
Dr. Fadwa.
Thank you very much for this nice lecture. Actually, it's challenging to teach chemistry now or science or anything. But I agree with you that we have to learn with our students, and maybe our students are better than us in AI. But What I really need to know, do you encourage teachers to encourage their students to use AI in their studying process? Do you think that it will add for their analytical thinking, or it's going to do the other thing around?
Yeah, that's very good questions. At University of Helsinki, it's encouraged to use AI in university level, and we are encouraging teachers to use it, but we have to be very careful at school level that how do we use it. So that's why we need this kind of pedagogical content knowledge or AI for our teachers, that they know how to use it ethically and pedagogically well. So as I said, there have to be critical thinking in case of AI. It's not good for everything, but I can give you one example. For example, how we use in exams AI. When we have one topic that we want to ask from our students at university, we first ask from AI, what is the answer for this question? And then we add this answer to exam. And then we ask our students that please give us what are the and at this AI answer, what are the challenges of this AI answer, and please give your view from to these challenges from the base of your lectures at university. So they have to reflect the things that they have learned at our lectures or
That's
papers.
really a very nice idea.
Yeah, so we are not giving them that please use AI, but we are using AI and giving them opportunity to reflect. That's we have found that good way.
You can use it in the bachelor and graduate level, but not schools. There should be restriction.
Yeah, that's true. It's good at the teachers and university, but we have to be careful with
number
young
of
students.
Can decide if you, do you think the number of students in the class might really dictate the approach the teachers can use for their teaching methods, especially in using AI?
Yeah, I think in some things they can use, but I think more important is use it like a reflection, that they have to reflect which one is right and which one is wrong in these answers. That not using that please write something and use AI. I think it's more like using like a reflection.
Yeah. Thank you very much. Thank you.
That's our experience. Yes, that was very good question. As I said at the beginning, that we have more questions than answers, so it's also in the case of AI. Okay, if you have still
question,
any.
Just a comment. This
Yeah,
is
that's
from
good
Hitam.
comment. Yes.
Our ministry is in the chat.
If may I jump in?
Dr. Mansour.
Yes, thank you.
Please, yes.
Actually, it's not a question, it's maybe a comment, but first of all, I really would like to thank you for your inspiring lecture. It's really excellent and enriching lecture.
Thank you.
Especially, your ideas on enhancing teacher professional agency in science and chemistry education, really inspiring and, thought-provoking. And just following the AI, maybe I just need to comment that it's there. We have to adapt. We have to use it. It has to be part of our learning process, really. And, for us, it's the biggest challenge for us as a teacher or educators. It's how to engage our student, and I think that's the biggest challenge. So I think the takeaway from your lecture is that you already focus on empowering teacher with the professional agency as essential for fostering innovation, improving science and chemistry education, and creating more effective learning environment for student. And this is the key, really. So once again, thank you very much for this, for fruitful, and inspiring lecture. Thanks a lot.
Thank you.
And
It
thanks
was my
for the
pleasure.
organizer for this meeting as well. Thank you.
Thank you. Thank you, Dr. Mansour. Thank you, Dr. Maija.
Hello.
We have here a note from our question from Abu Saeed Muhammad. Can we know the strategy of teaching that they use it in your country? We ask the question for what? To improve what we have now.
Yeah, thank you. Do you mean our
teaching
yeah?
That you use?
Do you mean our curriculum at school, or do you? Okay, so
yes, in your school.
We have this National Board of Education. Maybe I can try to find out their websites. They have our curriculum in English there. So maybe if you put National Board of Education and curriculum, you can maybe find out National Curriculum Finland. I try to find out if I find it. So we have here, okay, something. I share this with you. So here is one link. And if you also want to understand our education system, we have this kind of online MOOC course for our education system. And it's free of charge. And there is also more about our education and our curriculum. So I will share it also with you if you like to understand how we educate our students. But
yes, thank you.
I know that you are making also good work. Yeah. Okay.
Also,
Hello.
we can share for all of the
Do you hear me, please?
audience. Yes, Dr. Jawahar.
Yes. Hi, how are you?
Good. Nice to
I'm
meet you.
Dr. Jawahar from the University of Jordan.
Yeah.
We are so delighted to be here in this meeting. Thank you for the Jordanian Chemical Society, also Ibtikar Society.
Yes.
I want to talk about experience in science teacher preparation here in Jordan, in the Jordan University. We are working in a program for 1 year for preparing teachers, pre-service teachers. We inquire them with the skills, knowledge related to the best practices in science teaching in the classroom. Also, we focus on STEAM education, inquiry-based education, problem-based education, and virtual labs these days also. We also these days working and using AI in science education. So we are working to make our students more effective in the classroom. And thank you again.
Thank you. It was my pleasure. Okay, if you like to be in contact with me.
I want to mention that only that the lecture will be on the YouTube channel of the ICDA Ibtikar. And also we will send email for the audience or the participants in this forum for the slides. Yeah.
Yeah, thank you. It's
At the end,
they are free,
at the end of this forum,
free for you.
yeah. Thank you so much, Prof. Maija, and we are looking forward to continue our collaboration.
Thank you for this
Yes.
opportunity and have good evening. It's still
You
sunny in
too.
Helsinki. Maybe I go to walk
Yeah.
outside and
Yes.
and let's continue our good collaboration. Together we are
Yeah.
more. Thank you.
Yes.
Thank you.
Thank you so
Bye
much.
bye.
Prof.
Bye.
Maija.
Bye-bye. Take care
Bye.
all.
Bye.
Bye-bye from the Journal Communication
Yeah,
System.
you too. See you soon.
Bye.
See you. See you.
See you. Thank you.
ابتكار لتنمية الإبداع، الاستثمار في الإنسان.